Today, I'm going to show you how to use a velocity versus time graph to determine displacement. So, how this is going to work is I'm going to have you first just think about the area here uh, between the line on the graph and the horizontal axis. And so I want to figure out what is the area of this. And if you recall, the area for a rectangle or a square is just length times width. So in this case, I have the height of this thing as being 4 meters per second, or you call it the length. So it's 4 meters per second. And then I'm going to multiply it times my width, which I'm going to call 8 seconds. And when I multiply those together, I get 32 meters per second times seconds. And so that's just 32 meters times seconds over seconds. My seconds cancel out, and I'm just left with 32 meters. Well, what do meters actually measure? Meters measure distance. And so what we know is that this area underneath a velocity versus time graph, and I have to emphasize velocity because it only works for a velocity versus time graph, that area is the displacement. So the displacement then is the area under a velocity versus time graph. And under, I really mean between the line and the horizontal axis. So if it goes below, then it would be the area above it, but just between the line and that horizontal axis. Now this is cool. If displacement is area, and displacement, just so you know, is written as delta x. This delta means the change in, and x is position. So x by itself is just where it is, and delta x is how far did you go. So where did you start compared to where did you end? All right, so now let's look at a different scenario. So in this one, it's a little bit different. So up here, this one was a constant velocity. Every second, if I labeled each of these seconds down here on the bottom, it would have been 4 meters per second each every time, because you go up and you go over and it's still 4 meters per second. Up, yep, still 4 meters per second. Now I'm starting with a velocity of 0 because at time 0 seconds, it's at a height of 0 meters per second. And then as time goes on, I see that it's going faster and faster and faster. And eventually it gets to 4 meters per second. So how do I know how far this went? Because it's not a rectangle, but the displacement is still this area. And so all you have to do is know the area of a triangle. And the area of a triangle is 1/2 times base times height. And in this case, my base is 8 seconds and my height is 4 meters per second. And so I do this math, and I get 1/2 times 32 times seconds times meters divided by seconds. So my seconds cancel out. And I'm left with 16 meters. Well, that's very different. Even though in this previous question, we also had an ending velocity of 4 meters per second and it went for 8 seconds. It's not the same distance. In fact, it's half. And here's my goofy way of remembering it. If you're not sure how to think about a triangle as being half as much, if you had a sandwich and you cut your sandwich in half diagonal, now you have a triangle sandwich. Well, triangle sandwich, last time I checked, is half of the sandwich. And if I had a big foot long sandwich and I cut it in half diagonal wise, I would still have half of a sandwich. So my cheating way of remembering that a diagonal, or that a triangle is half as much as a rectangle, is think about cutting a sandwich in half. It's half. But enough about sandwiches. Let's also think about another scenario where I'm going to have an object that maybe it's sped up the whole time, but I only care about how far it went between, let's say, 5 seconds and 20 seconds. And let's say it was speeding up with an acceleration of 2. Well, if each second it sped up by 1 second, that means that at 5 seconds it'd be going 10 meters per second. And after 20 seconds, it'd be going 40 meters per second. So I'm just trying to align myself to what's going on here. And I want to know how far it went between 5 and 20 seconds. So I'm going to find this area, but that's gross. That's a trapezoid. Most people don't memorize the equation for a trapezoid, but what you can do is just take this trapezoid and cut it into 2 pieces. And now I have a triangle on top and a rectangle at the bottom, and all I have to do is take the 2 and add them together. And so the height of this triangle here is 30, and the height of my rectangle here is 10. And the width for both of them is 20 minus 5, which is 15. And so that means in the triangle bit that I have 1/2 times base times height, because that's a triangle. And so that's 1/2 times 15 times 30. So that means the area of the triangle is 225. And then I can do the same thing for the rectangle, but the area of a rectangle is just base times height. And so now that is 15 times 10. And so that's just 150. And so to find the total displacement between 5 and 20 seconds, I add these together. And so I get, for the trapezoid, I have 225 plus 150, which gives me 375 meters as my answer for how far I went. But what if you didn't know one of these? Maybe you were only given one of the velocities. How could you find the other one? Well, one thing to remember is that the slope is equal to your acceleration. And acceleration is equal to your change in velocity divided by your change in time. So if for the moment I only knew it was 40 meters per second at 20 seconds and I was trying to figure out how fast it was going at 5 seconds, I could start by finding the overall acceleration. Well, I would be starting at 0 and going to 40, so my change in velocity would be 40 meters per second. And my change in time would be going from 0 to 20, which is 20 seconds. And therefore my acceleration would be 2 meters per second squared, or meters per second per second. And then once I have my acceleration, I can use some of my kinematic equations. So if we're trying to find velocity here, we don't care about how far it went or where it started. But we do want to know our ending velocity at 5 seconds. And our starting velocity was 0. Even though it doesn't say it, it starts at the origin, so we're going to assume that that's 0. Our acceleration we just figured out was 2 meters per second squared. And the time that we're trying to figure out our velocity for is at 5 seconds. Now, if I wanted to find the velocity at 12 seconds, then I would put 12 seconds there. But right now, I want to know at 5 seconds, what is that velocity? So the best equation for me to use is that my velocity is equal to acceleration times time plus my starting velocity. And so this velocity at 5 seconds will be equal to my acceleration, which is 2, times time, which is 5, plus my starting velocity, which is 0. And so that means that my velocity at 5 seconds is 10 meters per second. If you have any other questions, let me know. Otherwise, the area under a velocity versus time graph is your displacement.